Continuing the first section of this course, in this chapter we'll be covering some core functionality for working with lists. We'll learn how to create a list with functions like range and table, how to generate visuals for different types of data. We'll cover how to also operate on a list with table and another function, map. And in conjunction with map, how we can construct and use what's called a pure anonymous function. Before we get to creating and working with lists, we need to know what a list is. Just like outside of computing, a list is how we collect things. In Wolfram Language, we indicate a list with curly brackets and separate each item in a list with a comma. We can make a list of almost anything, since it's a way to store elements and doesn't actually have to do with the elements themselves. So we could create a list that has numbers, strings, symbols, colors, images, and more. Later on, when we start to actually operate on lists, though, it'll be important that we know what type of data we're working with and therefore what operations make sense. The list by itself, though, doesn't care what type of data we have. Now that we know what a list is, let's make a list. There's a lot of functions in computations where we'll end up with a list as our output, so in this chapter we're going to cover just a few basic methods for generating lists. Our first and probably most simple is the function range. Range creates a list of numbers based on our inputs. If we give range one number, it'll create a list of numbers from 1 to the given number, increasing by 1. So range of 10 will output all the integers between 1 and 10. We can give range additional arguments to generate other lists of numbers. If we give range 2 arguments, the first argument is the starting number, and the second is the ending number. So range for 4 and 10 will give us the numbers starting at 4 going up to 10. We can add in a third argument that is our step or increment size. This is how much we increase between each number. If we set the step size to 2, we can get a list of numbers from 4 to 10, increasing by 2 for each item in the list. Another common and more flexible way to create lists in Wolfram Language is with table. Table will repeatedly execute some piece of code, usually changing a variable we indicate each time it runs, and return a list of outputs for those repeated executions. If we just want to use table to create copies of an item, we don't need to include a variable. Our first argument for table is the thing we want repeated, and the second is how we want it repeated. If we want to create copies, our first argument is what we're copying, and our second is how many times we want to rerun that code. So if we set our first argument to the color blue and the second to the number 10, we can get a list of the color blue 10 times. Table is more flexible than range in that we can set a variable that we're changing for each evaluation. The first 3 examples of this work similarly to range, but with the addition of a variable. If we have the variable n somewhere in our expression in the first argument, we can then make our second argument a list, where we first indicate the changing variable and then what number we want that variable to go up to. For this example, we'll end up with just a list of numbers from 1 up to 10. Just like with range, we can add an additional specification to that second argument that shows what number we want to start at, and yet another to set the step size to a number other than 1. An additional feature of table is that it can iterate an operation through a list of items. So instead of giving table a specification for a number in the second argument, we can provide a list of values. It will then repeatedly execute the first argument for each item in that list. Often, when we're working with a list of items, it might be useful to visualize the list. There's a lot of different ways you can do this, and the methods you pick will depend on what types of data your list contains. If we want to organize information on our page, we might find it useful to put the list into a row or within a column. If we're working with numerical data, we may want some kind of plot. If we have a list of numbers, an easy one to start with is list plot, which will plot each number as a point with the x value increasing by 1. Bar chart is another data visualization that works in a similar way, but with bars instead of points. Most types of data will have some functions that work on a list of that data type. For example, word cloud is a great option for visualizing the frequency of words when working with strings. Image collage is one of a few ways you could combine a list of images into one visual. We've gone over how to create a list and how to make visuals from a list. What if we have some function, some operation we want to do to every item in a list? One option is to use table. Table can iterate an entire expression. So as I discussed earlier, we can use table to do more complicated expressions with a changing variable. We can also use table with multiple variables by adding a third argument with additional variable specifications. And if you do have multiple changing variables, table is likely the best way to iterate on an expression. As with earlier, if we're working with a list of items, we can iterate through that list by changing our variable specification from those changing numbers to that list. Another way we can apply an operation to every item in a list is with the function map. Map takes a function and will then use that function on every item in a given list, returning a new list. We can see this in action if we think back on what we learned in the first chapter of this section and define our own function. Let's define our function to be the same operation we just did with table. We can then use map to use this function across a list of numbers. Our first argument is the function, and our second is the list, in this case using range to create a list of numbers between 1 and 10. Map also has a shorthand, which is often used instead of the full form. When we use this shorthand /at, we put our function first, then our /at, and then the list we want to use that function on. When we're working with map, it's important to remember that map doesn't need square brackets next to the function. That's represented kind of visually with the shorthand, with the @ sign, as that's an alternative way to use a function instead of using square brackets. Map, especially with the shorthand, might seem easier than table, but defining a function every time isn't the most efficient, especially if we're only using the function once within our map statement. Instead, if we use a pure anonymous function, we won't even need to define a function. A pure anonymous function uses a slot instead of a specific variable like how we've been using n. We want to end our function with an ampersand. This indicates to our computer where the function ends. If we've constructed it correctly, any slots we've been using should turn from pink, an incomplete expression, to green, a localized variable. We can then use a pure anonymous function just like we would use any named function. Where the function name would be, we instead put the pure anonymous function. This means instead of using the named function with map, we can just use the pure anonymous function we've constructed. In this chapter, we've covered some pretty core skills for working with lists in Wolfram Language. You now know that we can create a list for any type of data, and that we represent a list with curly brackets. We can make a list of numbers with range. We can use table to iterate an expression, which can be useful when we're both making new lists and operating on existing lists. Map is another way we can operate on lists by applying a function to every element in a list. And we can use a pure anonymous function with variables as slots and ending with an ampersand to make using map even easier.